you. Thank you, Mike. Well, good morning or good afternoon, depending on where you are. I want to acknowledge a few things and also give a very brief history of how Apollo came about. About 3 years ago, with support of U.S. Department of Energy, Apollo, which is essentially a real-time AI platform, was deployed at one of the largest facilities in the country, average treatment of 650 MGD with a capacity of 1700 MGD. And so when Mass CEC came along, they wanted to see if this can be deployed and scaled down to utilities that are mid or small size. And so we've been very fortunate working with City of Haverhill under the leadership of Robert Ward and Isaiah Lewis, as well as the town of Hull under the leadership of John Strazzuri and Brian Keeley to deploy and scale down these the platform. One notable partner to also specifically for the town of Hull is Woodard Kern, and Frank Cavallari in specific has been a great support as we deployed this. So let me briefly give you a background. If you go, Isaiah, if you don't mind, go to one next slide. So the agenda goes the following. We'll talk about Apollo, and then we'll discuss. Then I'll turn it over to Isaiah Lewis, and then Brian Keeley, and then we'll wrap it up with David Inman. Just briefly about Apollo, it is a national platform. So what City of Haverhill or Detroit or Louisville or Town of Hull, they're on a single platform. It consumes any source of data, whether it's SCADA, LIMS, external weather, telemetry, etc. It's all happening in the cloud. There's no infrastructure deployed on the ground. It scales to any size, as you're going to see, a 10 MGD average treatment versus 1.8 MGD. It's available on the phone to all the frontline operators. And it isn't just all about hard savings, but also retaining the knowledge that experienced operator has or managing risk. One specific thing I want to mention is really significant. Both these case studies that are being shared have been deployed during pandemic. It's very important. They were done virtually during pandemic. We had virtual meetings with the city and the town, but it didn't require a lot of heavy lifting of travel or being on the ground and on the site. So with that being said, let's hear from the real heroes. Let me pass it on to Isaiah. Isaiah, back to you.
Thank you, Mahesh. I'm not sure I'm a real hero, but I'm here to present. Let's start off a little bit about the City of Haverhill. First and foremost, I want to thank Mass CEC for facilitating this whole thing for us. And thanks to Mahesh and his team. They've been a pleasure to work with this whole time. So Haverhill is located in northeastern Massachusetts, and we serve a population of just over 60,000 residents. We have a co-permitted community in Groveland next to us who sends us around 200,000 gallons a day. We have approximately 200 miles of separate and combined sewer pipes. The sewer area covers approximately 6,800 acres, and the combined area covers approximately 1,500 acres. The city also maintains 36 pump stations and 3 siphon structures that carry the wastewater underneath the river. Piping network consists of pipe ranging anywhere from 8 to 72 inches with force mains ranging from 4 to 42 inches. Sewage is conveyed to the city's wastewater treatment plant via the South Mill pumping station. The pumping station is about a mile down the road. It houses 4 20 MGD pumps, around 400 horsepower each. And those pumps are controlled by the wet well level. And that wet well is controlled by a modulating gate that prevents flooding of the station. So we are a combined sewer community. So we can take anywhere from 5 to 65 MGD in a matter of about 5 minutes. This is the treatment plant. It became operational in 1977. It consists of screening, which is basically 2 fine screens, grit removal, which is 2 grit chambers that pump up to classifiers, and then we dispose of grit in the sludge dewatering trailers. Next, we have primary settling, which consists of 3 primary clarifiers and 2 gravity thickeners, followed by secondary treatment using an activated sludge process and disinfection with sodium hypochlorite. The effluent travels about 1,200 feet through a 102-inch sewer outfall that uses a siphon pipe to keep it full, and then discharges through diffusers into the main channel of the Merrimack River. On the other side of the building, we use 2 CF 8000 Westphalia centrifuges for dewatering. So Aquasight has deployed Apollo here. We've really been working with it since about October. The project scope included some major treatment processes, which were influent pumping, activated sludge, secondary clarification, sludge dewatering, and plant processed water pumping. The focus of the project is to minimize the use of resources such as energy, chemicals, and trucking in the treatment process, and a baseline cost was developed as shown in the table below. So we came up with a baseline cost of $2.847 million and identified approximately $164,000 worth of savings. A lot of that through trucking and energy costs. We found quite a bit of things that we need to work on. This is an old plant. We're getting ready for a secondary upgrade coming in the next few years. We're getting close to the point where we have an engineer on board where we'll start looking at what we need to do to get up. So influent pumping, we found that rehabilitation of pump 3 can provide savings of up to $6,000 per year. That work has been completed. We actually did some rehab work on all 4 of these pumps. Apollo has shown us that recently pumps 2 and 4 may have some additional issues and are running relatively inefficiently. So we're looking into that more closely. What else we found was, because we're an old plant, we don't have a lot of flow and pressure metering. So discharge pressure meters we'll put into a capital plan, and the potential for some better flow metering from the pump station. Activated sludge, they released a smart O2 advisor, which will help reduce energy costs by somewhere around $47,000 per year. RAS pumping advisor will also help reduce energy costs by $5,300 per year. So we are slowly implementing both of these things. When I jump into the app, you'll see that we're starting to see some savings, especially in blowers, and RAS will be shortly behind. We're still in the process of getting one on board and trained and ready to really jump into this. So plant water pumping, pressure set point advisor will reduce energy costs during non-foaming conditions by about $14,000 per year. We tend to have some seasonal foaming issues from filaments and things like that. So we use a lot more water in the summer than we do in the winter, and that's where the biggest energy savings will be. Sludge dewatering, the centrifuge smart advisor will help produce consistently drier cake, consume less polymer, and generate less solids volume, ultimately resulting in fewer truckloads. Reduced polymer usage could save up to 17 or 18,000 in chemical cost, and reduced sludge volume can save up to $80,000 a year in trucking costs. Oops, sorry. So value at the wastewater treatment plant for us, Apollo's digital buddy, as Mahesh calls it frequently, gives operators the tools to make decisions using real-time analytics. This guidance empowers operators and expands their knowledge. Apollo will provide valuable knowledge and analytics that can be used for future upgrades at the treatment plant. Each milestone we completed provided us with a list of considerations for all future capital projects. And as I said, Haverhill staff is still in the process of implementing the AI platforms. We are constantly working with Aquasight to further develop any insights from the app and the continuation of data collection. One thing about Apollo that we really enjoy is that it's not necessarily an app that tells you how to run the plant. It's using historical data and some industry insight to help operators make more informed decisions. And that's really important, with the staff that's been here, some of them up to 35 to 40 years. Operators tend to get a little set in their ways, and to use this as a tool to make better decisions is an easier way of getting them to jump on board with this. So I will go ahead and jump into the Apollo app because I'm sure that's what everyone is really interested in. So everyone can see my screen now still, I assume?
It's, you got to get off the screen share mode, Isaiah, so we can see the screen share mode.
Oh, sorry.
Press escape on the PowerPoint. There you go. Yep, it's coming now, Isaiah.
Okay, great. Little technical difficulties. I haven't used Zoom very often. There's so many different platforms out there. So, this is the app. The thing that my operators like the most, I give them all this new information and they say, oh, wow, we got a great weather application now. So the weather application is pretty nice. This was something we didn't expect, but it has a million different layers of different things you could want to see. And the operators were very impressed with that. If we move down to influent pumping, so this is our dashboard. It's showing our pump station, current flow. It's showing the wet well level. The pumps operate based on the wet well level. And it's giving us month-to-date costs and kilowatt hours per million gallons. Below, we get some pump insights where we're looking at live efficiencies. There were several assumptions we had to make, or Aquasight had to make, I should say, when developing all of this. We use the flow meter from the partial flume at the treatment plant, which includes flow from our co-permittee town Groveland and septage flow and things like that. So we had to back that out of the equation. Another problem was we don't have live discharge pressure readings down there. So Aquasight came up with a calculation using historical plant data from the operators to give us some really solid data here. System efficiency, and then down below it gives us the which pump is running and how it's running. And then we move over to analytics. And here we can take any given week and we can add layers, as many layers as we want to compare different things on the graphs. Secondary treatment was probably the biggest part, or one of the biggest parts of what we did here. It's what I use the most anyway. So it's giving us live influent flow readings The Smart O2 advisor is advising us on how many blowers we should be using. Our treatment system, again, is a little outdated. So we have 3.5 million gallon aeration tanks. 2 of those tanks have fine bubble diffuser. And then the third, which we try and use as a standby as much as possible, is still old mechanical aerators. Each tank has 3 blowers. So we tend to cycle between 2 and 4 and 6 blowers because it's hard for me to run 3 because it doesn't feed each tank. But we've been following this pretty closely, and we can plot out our savings here. And you can see since around September, October, when we started this, we are definitely starting to see some positive things here. Live DO insights on each tank is available. Aquasight team has, using historical data, has made a PEBOD estimate, so we can kind of see what we are live heading into the aeration tanks. And then next we have standard oxygen transfer efficiency, live readings, and blower performance. Again, the just an amazing amount of graphing and charts and things that you can do here. Every dashboard has something different that you can see with different layers. Secondary clarifiers, we're looking at live mixed liquor flow. And then we use some state point insights. We follow that to try and prevent any solids lost to the effluent. I can change assumptions whenever I want if I think that I know more clearly what we're actually operating at. These were built with some level of protection here. Surface overflow rates for the clarifiers, live operator blanket readings. The live operator blanket readings work much better for us because our ultrasonics are not completely reliable. RAS guidance, we're really starting to get into this now. Our RAS rates are a bit challenging because, as I said, we can go from 5 million gallons per day to 65 million gallons per day in about 5 minutes. So the difference in pumping is quite significant at times. So we have a strain on this advisor that allows us to go from 2 million gallons per pump to 3.5 million gallons per pump. And then again, you can plot your real versus actual. This October, we had a tank down, so that's why that shows that. And then we have wasting guidance, which is great as well. It takes the most recent MLSS and most recent WAS concentrations, and then you put in your target MCRT, and then we'll advise you on a wasting rate. It also shows live SVIs, solid masses, rolling 24 hours, just a wealth of information that was not previously available. And then we have blower health and performance, which is pretty straightforward, but we can choose any month and any year to take a look at anything we want to look at and plot it against each other. And then the decode, which is a great feature. It's usually a little bit quicker than this. So again, more layers. I can take a look at activated sludge and the secondary clarifier performance and plot things against each other for any given week. Solids processing was a big part of this because that's where we found we could probably achieve the most savings. We are still working with Aquasight all the time on this. So our centrifuges, if you look down to the right of the screen where it says sludge flow 166 gallons, this is currently, that first is what we're running at now. And the best practice is based on historical data from our operators under similar conditions to make recommendations on where we should be at. And then the optimal just expands on that. So we've been running pretty close to optimal for a while now. We do keep an operator in the centrifuge full time to make on-demand changes as the sludge changes. Aquasight has given us some thickening information on projected percent solids for what we're sending to the centrifuge. It's a blend of settled primary solids and thick waste activated sludge. And it's giving us information on what our exact blend was, primary to secondary, and how much is in the actual blend tank. And then we have our actual feed solids. And then below, we can see where we are cost-wise on a daily summary. And then we can plot that out and see where we've been in the last several months. Centrifuge dashboard. It gives us performance and health, and we can plot that once again. Plant water management is still a little bit of a work in progress. Our plant water system, we found through this project that we are probably a little bit over designed. And so there's going to be some, we will take a look at that as we do the secondary upgrade here at the plant. But there will be some pressure advice at some point. And then below you can see the pump insights. Obviously the efficiency is not where it needs to be, and system efficiency, and then the pump that is running at this time. And then we can take our analytics from plant water management, and we have the decode dashboard once again with many different layers that we can compare to each other, and pump performances, pump statistics, and system statistics. And we can look at these on a weekly basis, monthly basis, or yearly basis. Lab insights is something we use a lot here. We can plot multiple different parameters together here and take a look at things that we want to see together. And then Sammy is our digital buddy who, in the settings, you can determine what you want to see for different alarms and what the set points are of those alarms, and then that actually will send a report at the following business day every day. So that's pretty much the app as a whole. So
Leslie, is a Q&A right now, or is it afterwards? Specific to the city of Haverhill.
That's a great question. I think it's really up to the audience. If the audience has any questions, they can submit them at any time in the Q&A box. So I don't see any in there yet. So maybe why don't we just go to the next set of slides, and then we can take them all at the end, because I don't see anything in there quite yet. Okay.
So I guess just to everyone in the audience, if you have any questions, could you post it in the chat box, please? And if not, you could speak live towards the end of the presentation.
So Mahesh and presenters, you should be able to see this questions and answers box as well. There was a question that just was submitted.
Okay, so there was a question, any concerns with internet security? Isaiah, do you want to speak to this, or and we can also?
Yeah, you might be a little better with internet security questions. We had my counterpart at the water treatment plant worked a little bit more closely with you guys to set all that up.
Right. So the connection, as Isaiah said, the connection of the data that would feed into this, plus external data that's coming from many other sources, is done through the business network, not through the process network. So the risk of hooking up to directly to a process network is removed. That's one thing. The second thing is it's only read-only, it's not write. So all of the data is doing is reading the raw information that's coming into Apollo, and there's nothing being written back. So you have a secured lock into a specific port and what's being going out. And there's several other security considerations. If you want to send us your email, we're happy to give all the details on the security infrastructure. I think there was another question that come up.
Yes, there are two other questions in the Q&A box, if you look at the ribbon on the bottom, and then there's one that came into the chat box.
Yeah, so this is the question, Isaiah, and perhaps when a facility is set up new, does it work with existing sensors and testing equipment, or do we need to retrofit additional measuring equipment? I think you can point to that, Isaiah, and then if you need me, I can add to it.
Yeah, no.
Do you need to install anything new? Okay.
We did not need to install anything new. It was just getting Aquasight access to our LIMS system and to SCADA to transfer that data. Obviously, as I said, we found some things that we need to do to get better data, but we did not need any retrofitting or anything like that.
And if I can just build onto that, one of the beautiful things that happened in this specific case with the city is everybody would think, you would need an airflow meter coming out of the blowers. And that's critical to do everything that Isaiah talked about. What we have done is after we recognized there was an airflow meter, we worked closely to put in place a soft sensor, which is essentially reading live airflow meter without having an airflow meter, by taking into consideration other information around the blowers, plus the specification of the blowers, et cetera. And I believe as part of the capital plan, you will be installing a new airflow meter soon here, I think, Isaiah.
That is correct. The plan is to get all new blowers altogether, but we'll see how soon I can get that done.
Yeah. There was another question come, are all of the outcomes from Apollo or Aquasight is advisory? Isaiah, you want to say, is it all about advisory that you're looking for, or are you looking for other things within the platform?
A lot of it is about advisory, but the platform itself gives us a lot of different live data that we wouldn't have had before to make informed decisions, elsewhere. But the advisory portion of it is big for us, yes.
And there's another question that come up, Isaiah, you could be able to answer. Is this coming via SCADA, or is it a separate screen than SCADA or DCS?
It's a separate screen that Apollo is a web platform that we go to, and it's pulling all the data.
Right. So the SCADA and Apollo are two different screens, and in the control station, you would have two different monitors, so to speak. SCADA for control, Apollo for performance, and things like that.
Right, and we tried to, kind of work with Aquasight to develop the app the way that we want to see it. Obviously you don't want redundant information, so we like to see, new information other than what SCADA can provide.
And then one more question came up, Isaiah, Sammy, how soon does it report? You started using the daily urgent versus non-urgent. Can you report on SAMI?
Right. So yeah, there are a couple different set points depending on how you want to see it. Any urgent alarms will come up automatically. Anything that's not urgent, you'll see in the dashboard. And then I think it's around 8 a.m. every morning, I get a report for the previous day. But you can customize that however you want. It's really what you want to see and don't want to see.
Okay, that was a fire hose of all the questions. So thank you, Isaiah. Maybe we can pass on the control to Town of Hull.
Okay, great. Thank you, everybody.
Thank you, Brian.
Hi, this is Brian. Can everybody hear me?
Yeah.
Yeah, we can hear
Okay,
Brian.
good.
Brian, can you share your screen as well?
Sure. Yep.
Yeah.
Let me just get this rolling here. Okay. So I think I'm sharing the screen. Is everybody with me?
Yep.
Okay. All right. Well, first of all, thanks, Isaiah, for that demo. And also thanks to Mahesh and his team, as well as Leslie and the Mass CEC team. Everyone involved has just been fantastic to work with, and it's been a great pleasure. Also, I see a few attendee names I recognize from the industry, so that's cool. Welcome, everybody. So my name is Brian Kiley. I'm the Assistant Director of Wastewater Operations for the town of Hull. We're not joined today by our Director, John Struzieri, and we also have, we have 2 admin staff, and we contract our operations an aerial shot of the whole town here, and I circled the location of our treatment plant here. So we're kind of almost out at the end of a really long peninsula, and it's really a great place to be, especially in the summertime, as you could imagine. So we actually have a bit of a seasonal population where, you know, in the off season we're about 11,000 people, and in the summertime I think it just about doubles. So the plant out here, the startup date was in 1978. We're about a 3 megagallon design flow, but we usually see around 1.8, 1.6 on average. And, you know, in storms, we can see up to 12 megagallons. You know, we're obviously quite a bit affected by coastal storms, as well as the tide. I mean, a lot of these pipes in our roads, they're actually below sea level. So as you can imagine, with infrastructure this old, we see a lot of I&I effects due to both, you know, tidal cycles and precipitation. So, but the plant here, it's a conventional activated sludge plant. The collection system, we have 7 remote pump stations, and we also receive flow from the town of Hingham as well, through an intermunicipal agreement. And we have 43 miles of separated sewer, and Woodard and Curran, they help us out with the operations. And a big thanks to Woodard and Curran and Frank over at Woodard and Curran for helping us get involved in this project. So I included a few pictures here. You know, as you can see, coastal storms and flooding, it's a pretty big deal for us. You know, we see high peak flows during storms, and as well as that, we also see localized flooding here at the treatment facility. You know, there's this, if you see this second picture over here of the chlorine contact tank overflowing, there's actually a rock revetment in the background there. So that actually, we see quite a bit of wave action, you know, crashing over that. And a lot of that flow just ends up coming right into the facility grounds. And, you know, so we see a lot of localized flooding here at the treatment facility as well. And you know, it takes a toll on all the equipment. You know, the salt water, the salt air, just, it deteriorates everything. Equipment, pumps, valves, you name it. You know, and in addition to that, hydrogen sulfide having such a long collection system. And of course, we also see wipes, debris, stuff like that, as, you know, same as everybody else. So the scope of work for this plant. So actually, to follow up on one of those questions as well, we actually did have to install new transducers and set up a DMZ, demilitarized zone. I won't pretend to know exactly what that is, but I'm sure one of the folks at Aquasight can fill me in there. So, and then it connects to SCADA. So first thing we did was establish the baseline energy metrics. This would allow us to identify the opportunities for savings. And then we went ahead and implemented the Apollo software and started analyzing the data. The modules that we had, so first of all, the influent pumping, activated sludge, which consisted of both of aeration and RAS pumping. And then we had an effluent pump station module and sludge handling. And what made our project unique from Haverhill is that we actually added a collection system module. And my demo and a lot of my presentation is going to be focused on the collection system module. I didn't want to make this presentation redundant to Isaiah's. So we can expand on that collection system module moving forward. And what we did there is analyzing the flow meters and pumping data. And finally training and adoption. And also Aquasight was kind enough to add a lab insights module, which analyzes our lab results. So we thank them for that as well. So actually, I guess I can get right into the demo here. Let me just pull this up. Okay, so is everybody with me?
Yeah, we can see it.
Okay, good. So here's the home screen. It's your weather standard Doppler screen that I'm sure looks familiar to just about everybody. And then over here on the left, you have the different modules, including the lab insights down here at the bottom. So I'll just go ahead and I'll just go ahead and click on the collection system module, show you what this is all about. So this is the dashboard for the collection system module. As you can see, we have 7 pump stations throughout town. It's kind of a fishbone structure that all leads to the treatment plant right here. And so how this all works is the flow meter data is collected over SCADA and analyzed by Apollo in real time. And pump station 5 right here, this is actually in construction right now. So we have that pump station bypass. So that's why it's zeroed out there. But you can see, so actually it looks like the only one that's pumping right now is pump station 3. And yeah, that's it. So let's see. So pump station 9. Actually, I can go over pump station 9 out here. So this pump station is actually the one that's in probably the worst shape, and we have a full replacement of that station in design right now. It's at about 50% design or so. But the rest of this dashboard here, so obviously, over here on the right, you can select from which of the pump stations you want to look into. So if we, click on pump station 9, down here, the weekly capacity, it's a 900 GPM pump station capacity. So as you can see, our average hourly peak is currently about 92% capacity. And right below it, it shows you the monthly has been calculated by Apollo based on the flow meter data and precipitation and also, probably unique to the coastal communities is Apollo's actually analyzing the tide cycles as well. And down here, you can look at the rolling 24-hour graph of pump station 9 flows. So what you have here, and I can actually turn on the tide as well. So here's your tide cycle right down here. what these numbers are. So you have this black line is your real-time flow, and then these other dashed lines. So you have your average dry and wet weather flows from the previous year. And then there's also the previous year monthly average, which is this PYM line right here. So that's what those mean. And yeah, so that's the dashboard. And over here, if you come over here and click on analytics, we can look further into it. So I'll start with, I guess we'll start with pump station 9. Yeah, let's turn on, so monthly, actually let's start here. So we'll look at last month. So as you can see here, out of all our pump stations, pump station 9 sees the largest proportion of inflow and infiltration. And of course, there's also the area that's directly tributary to the treatment plant. And that's another story, but you know, so that's a lot of flow right there. But all this flow, this is mostly not being metered at a pump station. So this is all like if we were targeting I&I reduction, you know, I&I control efforts, or if we were, you know, putting together a sanitary sewer evaluation survey consisting of CCTV inspections and smoke testing and stuff like that. I mean, this right here tells you exactly where you need to look. So it really, you know, allows you to focus your efforts, and you know, that way you're not going to, say, the pump station 6 tributary area and, you know, spending a bunch of your SSES budget on CCTV in that area. You know, obviously there's actually not much I&I at all there. So you can see how this really, I mean, this can really allow you to focus your efforts tremendously. So let's see. So let's come up here. We can click on the node and look further into pump station 9. So this is the last 12 months, looks like. So as you can see, some months greater than others, but you know, you can actually turn on the total rain right here, and you can see exactly why we have so much flow in December of last year and February of this year, last month. Those were higher precipitation months. So obviously that's why you see a lot more inflow here, which is this green section of the bar. And the blue section of the bar obviously would be infiltration. So that's actually mostly due to tide cycles around here. Whenever you see a higher tide cycle, you see a shoot up in this infiltration, and we can actually see that in the data. So going up here to decode, so we can actually dive further into this. You know, go to pump station 9 here, and we can look at the last decently sized storm we had. I think like the end of January was about when we saw a good sized storm. So yep, here it is. So these blue bars up here, this is the rainfall that was recorded in that hour. And as you can see, you have these inputs of rain into the system, and it takes a little while, but eventually causes a spike in the flow here. And this one's pretty significant. You know, that's like, what's that, like 8 times or something? Yeah, that's, you know, that's a good spike right there. And, you know, and then you can see it, you know, it tapers off here, but you can notice these little humps here. So if you actually come down here and turn on the tide cycle, you can see that those actually match with the tide cycle. So, you know, the higher tides, because, you know, with the storm, you actually get a storm surge during the tide. in the tide cycle as well. So these tides are actually higher than normal. And you can see the spike that it adds to the pump station flows as well. It eventually tapers off. And let's see. So yeah, I mean, we can also see that. So if you go to the water treatment facility data, you can actually see that over here too. And like I said, pump station 9 and the area tributary to the treatment plant are obviously the biggest contributors to our I&I problem here. So you see that pretty clearly in the data. And
hey, Brian.
Yep.
It might be worthwhile to explain why I&I is linking to the plant efficiency play, because over 56, 57% of the flows is I&I coming into the plant. So can you explain that a little bit to the audience?
Right. Yeah. So I&I, infiltration and inflow. So inflow would be more, due to rainfall and precipitation. So, you might have open pick holes in manholes and stuff like that. And then infiltration would be infiltration into manholes or into pipes, leaky pipes, leaky manholes. And we have plenty of those in town too. I mean, a lot of our collection system is 50 years old, but some of it is actually, dates back to the 1800s, late 1800s. So, I mean, particularly in the pump station 9 sewer shed, we have a lot of old sewers up there, and that's what's contributing to the problem there. And we actually have an SSES program right now where we're looking into a lot of these areas and with CCTV and smoke testing, flow metering, and we're trying to identify these areas with the high infiltration or high inflow and try to reduce those, because ultimately when you reduce the flow going to the pump station, not only do you decrease the amount of energy that you're spending pumping that flow, but then you're also decreasing the flow to the treatment plant. And then so then on that end, you're decreasing the energy use in the influent pump station, in the aeration system, in the secondary treatment, and the effluent pumping as well. So I mean, every gallon that we can reduce from our I&I, it saves us probably a good amount in the long run, and that's what's really useful for us. But also, I know a lot of communities are maybe capacity limited, and that's not actually something that we face in Hull. Our treatment plant was built at the time that the town was mostly built out. It has been for a good number of years. So we're not really facing capacity limitations at this point. We're just trying to control I&I and upgrade our system to save on energy costs and stuff like that. But I can imagine for a lot of communities around here, I think they might be facing issues of capacity limitations, and maybe it's much cheaper to control I&I than it is to increase your permit level and upgrade all your equipment at the treatment facility and all that. I mean, a program like Apollo might be able to identify a much cheaper way to go about it than getting into a huge capital improvement project where you're upgrading all your equipment and pumps and all that. So I'll just I guess that's it for my demo. I'll get back into the the slideshow here. So we went through these. So just to wrap up the analysis of our collection system module. So the average I&I from 2020 ended up being about 56% of the total flow, quite a bit, as you can imagine. And based on our energy baselines, so if we were to target 50% reduction in that I&I, we could end up with a savings of 30,000 per year. And that would all be coming from not only reduction in the treatment facility pumping and equipment energy costs, but also additional savings at each pump station. And not only that, but it also decreases the budget that we have to allocate for like an SSES program, because we already know which areas to target. We already saw pump station 9, pump station 3. We can target our efforts there, and not waste our time on these other sewer sheds that aren't seeing much I&I. And also, we do have a pretty large large for us, $50 million capital upgrades program over the next several years. And the insights that we're getting from Apollo really help us steer those design decisions. So the design teams are actually taking this Apollo data and making their design decisions based on its insights. So it's really, I think you can see the value there. And so some more lessons learned from each of the, from the collection system module. So I won't read through all of these, but as I think you saw, stations 3 and 9 have high infiltration. So we're definitely going to target those on our I&I efforts. And as well as infiltration sources at unmetered sites near the treatment plant, which all requires more inspection and maintenance. And as I said, now we know that, and we can target those efforts accordingly. And as I mentioned, so the high infiltration suggests the broken, leaking pipes and joints, and also manholes as well. Sometimes you'll see a huge gush of infiltration in through like a pick hole in a manhole. And sometimes it's really easy just to plug that up and grout it, and that might keep out a lot of flow
Brian, sorry,
Yep.
It is Leslie. I just wanted to let you know you only have about 2 minutes left.
Oh, sorry. Okay.
No, that's okay. This is great. I just wanted to at least let you know there have been a question or two, I think, that's been submitted, and just to let you know we only have 2 minutes left.
Okay, sounds good. I think I'm wrapping this up anyway. So yeah, we do have a success story where we saw a huge spike in flow at pump station 3. There was actually a small piece of PVC pipe stuck in the pump check valve, and we wouldn't have known what was going on here, except that we saw it in Apollo, which allowed us to go investigate further, and the operators ultimately removed that PVC pipe from the check valve and returned it to normal operation. And so yeah, that was a really cool success story. And these are the results from the various modules. As you can see, we found a few great areas of identified some great cost savings here. So that's it for my presentation. I know Aquasight has another slide here that they can get into, but I'll take any questions as well, since I know we only have a couple minutes.
Yeah. Are there any questions for Brian? There was one brought up, Brian. Were you able to identify any energy efficiency in the collection system? I think it was not doing pumping performance. It was just trying to do more I&I assessment. But if you have any response to that question from Mike.
Yeah. Yep. So actually, I mean, we were figuring realistically, I think, you know, maybe 50% of that we'd be able to plug up. So that right there we calculated a savings of about $30,000 per year, based on pumping and equipment energy costs. And that's just at the treatment facility too, not including energy costs at each pump station as well.
Right.
Mm-hmm.